Hello everyone, myself Dr. Sreenivas Padala. I am from Ramaiah University of Applied Sciences. Currently, I am assistant professor in Department of Civil Engineering. My specialization is in construction management. I am from India. I am very excited to be part of this BIM Coordinator Summit 2023. So in this summit, I am going to present a research study. The title of my presentation is BIM-Based Schedule Change Impact Analysis in Construction Projects. So in this presentation, discusses the various BIM applications to quantify the various change impacts towards the project schedule and cost overruns. So we all know that any construction projects can be called as successful if it is completed in within time and within allocated budget. Again, satisfying the quality and other safety requirements. But as of now, the biggest problem we have in our industry is handling changes. Like how to identify the various changes which can arise from architect, designers, mechanical, electrical, plumbing, from construction. So you can have several changes which can originate from different domains, and these changes are inevitable. So currently, the biggest problem is how to identify them as early as possible and resolve it so that we can complete the project within the same deadline without compromising any additional time and cost overruns. So what I've done is initially in my PhD work, so I had done one exploratory case study in various Indian construction projects. So you can see in this table that I have analyzed various changes which are executed in various metro projects, various construction projects, and various residential projects. So there are total around 19 projects I have studied, and you can see in the third column, each project has resulted into several changes, like huge number of changes, starting with metro station 530 numbers, then P9 commercial buildings has around 365 changes, then registered buildings has around 150 changes. Like so, every project has a lot of changes. Like there is no project which cannot be executed without any changes. So I also analyzed the time and cost hours due to changes only. You can see that it's ranging from 56% to 100% for schedule cost overruns, schedule overruns. And for the similarly for cost overruns, you can see the range. It starts from 13% and it is going up to 28% or 26%. So you can understand from this that changes are inevitable and it can increase your project cost and time. And if you can't analyze those changes, we can't identify them as early as possible. It can have a significant impacts, which is it can be detrimental to the project stakeholders' investments. So what I've done is I try to understand where the changes are happening in a project. If we start any project, we have decision-making process, right? Especially in design phase. So I try to analyze or identify where the changes can happen. So I found that changes can happen from architects, changes can happen from the design point of view, changes can happen from contractor point of view, or due to constructive analysis. Changes can also happen from MEP, mechanical, electrical, plumbing requirements. Sometimes changes can also happen from external factors also, which is not in our control. So only the internal changes, like our project specific changes, can be controlled. So I also found that. So I studied around 3,951 changes which occurred in 19 projects. What I observed is most of the changes are actually originated or resulted in the construction phase. You can see here in the graph in the below, all the type of changes. So I have studied various type of changes like client related, design related, interface related changes. Then we have external related changes. Then we have construction related changes. Then sometimes there are also some changes which can happen to improve the performance of the project. So most of the changes are happening in the construction phase, which means that you have to stop the project, you have to redesign the work. Again, you have to restart the work. So it can increase the project time and the cost drastically. So considering this as one of the biggest problems, so I have proposed a BIM-based methodology to identify and quantify those changes. So the main research question is how to identify those changes as early as possible. The first question. The second question is how to quantify those changes as early as possible so that we can implement and revisit the cost and time estimation. So this is my proposed a flow chart, which is based on the BIM concepts. So you can see that I used Autodesk Revit 3D software, and I also used Autodesk Navisworks, which comes under 4D 5D dimensions. I also used Microsoft Projects to develop a schedule, then later import into the Navisworks. So I applied these three dimensions, 3D, 4D, 5D dimensions in these projects. So I'm not going to cover again what is these dimensions and all. I think there are a lot of experts already there in this summit. I think even from audience also point of view also, I hope that everyone understands the basic concepts of BIM. So in this presentation, I'm going to cover only the application part, like how I used BIM application of BIM concepts to resolve the change impact analysis. So you can see the flow chart. I'll just brief it. That I'll started with developing the 3D models of architect model, structural model, and MEP model. So I went to I went up to level 4 details. It was very in-depth detailed modeling is done. Then I developed a 4D scheduling. Then after that, I done even quantity takeoff. Then finally estimated the cost. So these are the planned model. You can say as planned model. Then changes can happen due to various reasons, as I told you. The external changes I'm not focusing, but especially changes due to clashes of the different models I have executed. Then some changes also happen due to other causes, due to the change in requirements of the owner that also executed. Then accordingly, I revised the BIM models, then again revised the 4D and 5D model. And finally, I compared as planned and as built model to determine the time and cost overruns. That's the overview of my flow chart of proposed build methodology. So I applied this BIM concept in one of the office building in India. So I can't disclose the location and specific details of the project due to some confidential issues. So I can see, but as you can see that it's a commercial building. It's a commercial office building. It is a G+6 building. And it is again, it's just one other tower, the project. So I'm not applied for entire project. So you can see it is G+6 building. Ground plus additional 6 floors. So each floor has a sufficient office space. It has meeting rooms, it has manager rooms, it has kitchen, toilet, store, lounge, and corridor rooms. So I model first architectural plan, architectural model in the Revit model. So this is your architectural model. Then I have modeled again a structural plan, the 3D model of a structural plan. So I have considered the footings, columns, beams, everything, and you can see on the bottom the footings actually taken care. It's a shallow foundation again. So I also modeled HVAC, such as ducts, air terminals, diffusers, fan coil unit, all the basic necessary elements which are required for HVAC details are modeled. You can see the level of detailing is done in this building. Then I also modeled the fire plan. So all the firefighting related like sprinklers, pumps, hose rail, pipes, water tanks, everything is modeled in 3D. And I can see that 2D plans are automatically generated. That's the best part of the Revit. And we can so you can also eliminate changes due to errors. These type of errors can happen. We need to redesign, redetail, how to do. Those can be eliminated. So these type of changes can be already eliminated using 3D model. And we know that all these are done before you start the project. So you can again revise this 3D model n number of times without wasting labor, material, equipments in the projects. Similarly, this is for electrical layout, a 3D model of the building. So such as cable trays, lighting fixtures, switches, MCP, conduit fittings, even all possible elements which can be modeled, have done everything in these projects. What you see in the right hand side is a ceiling view of electrical layout. So this is a 3D plan of a building. So you can see the 3D model of plumbing layout. So all the necessary elements such as plumbing fixtures, pipes, everything is modeled in this Revit software. Then the next process is integrating all the models. So all the models, architectural, structural, HVAC, fire, electrical, plumbing, all the models are integrated in Navisworks software, Autodesk Navisworks software to get a single BIM model. So when you're actually modeling this together as an integrated model, we know that we'll get several clashes. So the main issue is that only, basically, if we don't apply the BIM concept, we can have several changes which can happen to the clashes, which can happen in construction phase, which is very dangerous. So using these BIM principles, I am able to identify those clashes and resolve all the changes in this model. So which I'm going to show you in the further presentation. So before that, I also done a quantification. So automatic quantity takeoff also carried out, and we know that that's another best part of the BIM. So you can also eliminate various changes or various errors in quantification of the major elements. So you can see first instance, so founding, footing, foundation, plinth level, structural column, structural framing, floors, stairs. So everything is quantified basically, and it is done automatically. So one of the main part of this presentation is to analyze the changes which are happening to the clashes. So I have integrated 6 models. So I have detected various clashes. So I will show you the next table. So you can see in this presentation, this slide. So there are different type of clashes can be observed, starting with architectural, structural, architectural HVAC, architectural fire, and similarly structural to HVAC, structural to fire, then HVAC to fire, HVAC electrical, then fire to plumbing, and so on. So you can see there are a huge number of clashes identified in this G+6 building. So there are around 16,586 clashes. Some of the clashes are repetitive, like 4 to 4 if you take, some of the clashes are repetitive. So what I observed is more than 4,000 changes are actually implemented in these projects to resolve these clashes. And these clashes can be different types, as I shown you. And the changes can be different types. So some changes are related to routing, rerouting the networks, changing the location of the walls, changing the size of the cutouts. So like that, you have several changes are executed in these projects. So due to time limitation, I'm not exactly actually showing the all the change details, but just for understanding purpose, you can see it here in this slide. So I can able to track the changes. I can also implement the changes digitally before you start the projects. For example, you can see on the left hand side we have before change model when the clashes are happened. In the right hand side, what you can see is the result. Clashes are resolved, and you can see changes are implemented here. You can see that there are changes in the HVAC components. Similarly, you can see in the plumbing works in the below picture. You can see that it is visually appealing that you can see there is a change in the walls. The plumbing components also slightly, the location is modified. Also, you can see there a shear wall is there, which is removed from there. So there are a lot of changes that happen like this, which are resolved in this project. Similarly, this is another example. You can see here again firefighting and HVAC, also in terrace. Also, you can see that there is a before change model. We have after change model. So one of the best part is here, the clashes are resolved, changes are implemented in this model, and then these models are again exported into 2D plans, then they are shared to the contractor. So what happens is we can actually minimize all the changes, or you can actually avoid all these type of changes in construction phase, which can delay the project drastically. So once the changes are resolved, I mean, this part is like what is the sequence of changes, like how the clashes are resolved. So started with analyzing the resolving the clashes and implementing changes from firefighting plans, then electrical plans, then plumbing plans. So first, initially, I focused on modifying the or implementing changes arising due to MVP clashes. Then in the end, only I focused on architectural structural changes. As you know that the main part of the building is architectural and structural elements. So we cannot start with those elements initially. If we start with that, we can have to again, it can generate even more changes. It can, I mean, it can propagate. Changes can propagate and it can have even more clashes if you are starting resolving changes or resolving clashes from architectural structural model. So this is a sequence I have followed. This is another insight which I gained in this project. So once the changes are resolved, another second part of the research question is how to quantify those changes. What is the impact of changes towards the cost, towards the time? That's another part. So we know that there are four different types of methods to quantify or to determine the delays or cost overruns. One is impact as plan analysis, then we have time impact analysis, then we have collapsed as built analysis, and as built versus as built as plan versus as built analysis. You can see there are different methods like for to determine the critical path. Some methods go with prospectively, some methods go with retrospectively, some methods go with contemporaneously. So we have different methods. So you can also see that delay also can be determined prospectively or retrospectively. So in this study, I have chosen time impact analysis basically. Where in this, what happens is in this, so logically the baseline program is prepared, then progress is updated in the baseline program. Then accordingly, the delay is forecasted. So at the different times. So how I done is I updated changes and revised the schedule every 3 months. Accordingly, I forecasted the delays for the project. So for that case, that purpose only, I used a time impact analysis. But I also compared as built versus as built analysis in the end. So in terms of analysis, I used a time impact analysis, but I also followed the basic requirements of as planned versus as built analysis. So this is what I'm showing is the progress tracking. So when the changes are implemented, so I also tracked the 4D scheduling. So you can see the level of detail again. So what happens is what you're seeing here is it's a 4D planned model basically. You see on the left hand side on the top corner, left top corner, you can also see the level of quantification. You can also find whenever you want to track the progress, you want to know for example, I stopped this simulation at structural column level 5. So as per plan, it should complete 67%. But if you see in the next slide, actually it was completed only 34%. So what is the reason is changes. Due to changes, several changes, the project got delayed. So you can see also the impact of time. You can also see the impact of cost on material, labor, equipment, and subcontractor also. So that you can also see the impact toward the cost. So if whenever any change happens, you can also determine the impact on material cost, impact on labor cost, impact on equipment cost. It is not only just overall cost, but also at the level 2, level 3 details can be also determined. Similarly, this is for MVP model. So since I cannot show you the MVP component, so I have just hidden the architectural structural elements. Here also same thing I had done. As per the plan model, you can see that level 3 fire layer should be completed, level 2 electrical layer should be completed. So you can also see the date here. So it's on Tuesday, 7 June 2022. On this date, this much work has to be completed. But if you again check the actual work, it is only completed around 38% only. You can see level 1, only level 1 electrical layout is completed, level 2 fire layout is completed, level 6 HVAC layout is completed. But as per plan, level 3 should be completed for electrical, sorry, level 3 should be completed for the fire, level 2 should be completed for the electrical layout. You can also see the total cost changes. So this is what you're seeing is as built, or sorry, as planned model. As per plan, the project should be completed by 29 November 2022, and the cost also shown in Indian rupees. This 57 crores, 96 lakhs, 42,250 rupees. But actually, due to raising of a lot of changes, the project got delayed by 17th March 2023. It is recently completed, and also the cost also increased here. The revised cost is around now 62 crores. So if you see here, the time overrun of this project is 11.52%, and also the cost overrun of the project also increased drastically by 8.16%. So that's the best part of this model is, so we can actually forecast these time and cost overruns, and we can accordingly revise estimates. It's just a simulation model of a 4D and 5D building, office building. So you can see the level of detail is carried out in very depth. So each element, even the small architectural elements, everything is modeled here. Then they are again linked with MS project schedule. So I prepared initially the CPM schedule in MS project software, Microsoft project software. Then accordingly, I imported that schedule in the 4D Navisworks software. Then accordingly, I linked all the activities with the task with the components of the model. So this model-based scheduling and model-based cost estimation is actually one of the best part of this study. So you can forecast the time and cost. You can forecast what all changes can happen also. You can also check where changes happen, how changes can propagate. Everything can be pre-planned, basically. So all this can be done before you start the project. That's the best part of the study. Similarly, this is for MVP building also. So this is for your structural model. So I hidden the architectural and MVP elements. So what I'm showing is only the MVP element, mechanical, electrical, plumbing elements modeling inside the building. So you can stop at any stage and you can check what should be the progress, what should be the time and cost progress. You can also check at what stage the project should be completed. And you can also compare with as built. So as the project is moving on, so I have taken the actual data from the site, that is a manually calculated data. Then accordingly, I remodeled this 14 5D model. So what are the key benefits of this study? So what is the insights which I gained? What can be the key benefits for all the participants in this study is? So one of the main benefits is we can identify all the changes as early as possible before you start the project. So changes that can occur in construction phase can be avoided. That's one of the main benefit of this BIM technology. Then you can visualize all the changes, all the possible changes, starting the architectural, structural, mechanical, electrical, plumbing, all the changes can be visualized. It will be adding a more clarity to the client as well as to the designer as well as to the contractor for everyone. Then finally, delays and cost overruns can be also visualized. That's another advantage. So again, identification of change components can be done quickly. Very quickly, you can identify changes. So when you're moving, let's say when you're changing the wall location, when you're changing the door location, it will affect the other components also, which can be identified very quickly. Then in the end, the best part is we can document all the changes. You can document all change causes. You can document all change impacts. You can document change attributes in structural manner. Even the causes, everything can be documented in well-structured manner. So what happens is when you able to document all the changes as you move on in the projects, you can also claim extension of time from the client with ease, basically, by showing as planned or as built comparison. So it will also make easy the approval process for getting extension time can be minimized. So actually, I am from, as I told you, I am from academician. Basically, I teach in university. So I have worked in various domains in construction management. Majorly, I focus on change management. So I have published various papers, journal articles. So you can, if you have time, if you, in future also, if you need any collaboration, you can go through this paper and contact me. So the presentation which I presented today, it is a part of the article number 7, which is published in Asian Journal of Civil Engineering. So for more details, if you want to know exactly what changes are happening in this project, what is the level of detail I went, what all type of changes are executed in this project, all details are available in this journal article. So with this, I will conclude my presentation, and I thank again the BIM Coordinators Summit 2023 team for accepting my application for presenting my research findings. These are my contact details. So I have given both my personal as well as my working email address. So again, I am from Ramaiah University of Applied Sciences. So I teach construction management courses for undergraduate and postgraduate students. And I also have around 4 PhD students who are working on construction management area. So I'm looking forward to attend other presentations also. If you have any questions, you can ask me now, or else you can always contact me. And I'm also eager to attend all other presentations and be in touch with you. Again, thank you.